all together. It's good to see so many people here in this room. I'm glad so many people came to our presentation. So my name is Moritz Eishold. I work on Xtext for, I don't know, 8-9 years now. We've been in many customer projects using not only Xtext but using code generation in particular. I work for Typefox. In fact, I'm a founder of the company Typefox. And yeah, so Christian and I want to talk about a lot of experiences that we made in the past that involve code generations and that go beyond writing text into a file.
Thanks, Moritz. Yeah, as Moritz said, I'm Christian. I'm also a member of Typefox. Not as long as Moritz. I'm not as long as Moritz in the business, but basically as long as Moritz with Typefox. And just let me start. So when talking about when using code generation, is about code generation templates, like I brought you here. This is a very simple code generation template in the code generation language OAW Expand, which is not the youngest one, but it's a good example for this presentation. So this simple template is called generated class. The input from this template is an entity object, and the generated result is supposed to be a Java class. Straightforward, and this Java class is, well, the template of this Java class consists of the template text with white space contained, some directives like this define for each is, and so on, and some escape expressions that refer to this template. These expressions are evaluated, and the resulting string is mixed into the fixed template string. I guess I don't tell nothing new to most of you. So this template is really nicely done. So it is properly, the code is properly indented, the blocks are indented. It looks really nice, really cleaned up. So the writer of this template did a good job. So, but the question that always came to me when I'm facing such kind of templates, how might the generated result look like? Will it be similarly nicely formatted? Will it similarly nicely look like this one? And so I was perhaps talking. So the question is, what about the results formatting? And what I did, I just used this template. I just generated a little bit of code for example data input, which is a car, which has some attributes, engine, automatic transmission, number of seats, and so on. And the task of this template was to generate this Java class, to generate these fields, and to generate getters, and an equals method. And as you can see, the formatting of the template is basically a mess. I mean, this is not that bad, but this is because the template is quite simple and quite small. But apart from these lots of white space which is contained in here, the indentation of these fields, this methods declaration, and this fixed method is different, and this is usually not what we want to see, especially when we generate different syntax than Java code. So what we actually expect is a nicely cleaned up, formatted Java class like this one. So what I next did is, in order to obtain such a nicely formatted result, I tweaked the template. And what I ended up with is this one, where the indentation is broken. Here, even nested indentation needed to be completely collapsed. And I tried to tweak suppressing some line breaks with these minus symbols, but it didn't work at all. That's another story. But the final question is this kind of template tweaking acceptable? And in my honest opinion, I have to say no, not at all. So this problem is, we refer to this problem as the formatting dilemma, which is about getting a well-formatted result like we have here on the left, based on a well-formatted template like we have here on the right. And the dilemma, actual dilemma is that with the established techniques like this OAW, like JET and other templates, you have to choose. There's no way of having both. And this is really unsatisfying situation. So unfortunately, we have a solution for you, which are the extents, the template expression as part of the extent language. And what I did next is I created the same template, I migrated this template into the extent language, and as you can see, it looks basically the same. So we have the declaration of the template with its name. It takes an entity as an input. It consists of fixed template text. It consists of dynamic content wrapped in these French quotes. We have the similar declarative or directives, but this template language distinguishes significant whitespace versus insignificant whitespace, and this is makes a big difference. And how extend actually, or how this works out actually, I want to show you on a small example. So let's focus on this one, and let's just have a small look into the actual implementation of this template, because the difference of extends template expression versus the former mentioned one is that extend is completely compiled into Java code. Many or some of you may have used it already. So it is translated into Java code. It's not interpreted. So, and if we have a look at the Java implementation of the loop over here, we can see there are some attributes. If we have a builder pattern, we have a builder object, and these parts of the template, the significant whitespace, the fixed template text, as well as the results of these expressions are consecutively fed into our builder object. And by this means that we can distinguish the significant whitespace and this insignificant whitespace, we are able to get a formatted result as we seek for. And if you don't believe me, I will show you in a minute. But I have one more thing. Staring at this template again, when staring at this template, I get another question. Why the hell is this import in there? Because, I mean, we have so many escape things to some expression. Why do I have to name a class, an existing class, by its name and take care about this import in here? Is there any better solution? And even worse, we generate these attributes, these fields, and we generate methods in here, and we refer here to types, or we generate types. And what if they are in a different package? So where can I get the information on these types? This is not possible, or in general not possible to get this in advance. And in order to check out ways to fix this situation, let's have another look into the generated Java code for this template. At least at the beginning. So what we can see here, we have a similar method called generate class, takes an entity, and the first thing that happens here, there is a builder object created, which is called a string concatenation, and the string concatenation receives all the template content step by step that we can see here. So we have the package thing and dynamic content And the cool thing would be if we can get rid of this, but instead put not just via this append method strings like we do here or here, but get or append a class object, for instance, to track this importing. And is it possible to somehow customize this guy? And I'm really proud to say, yes, we can do this. So let's get back to the template and let's modify it a little bit. So what I will do, next step, I get rid of the package declaration because we need to somehow create this thing and also create this and restrict to just the class declaration, which looks like this. And what I did further is I introduced this return type called string concatenation client. Kind of a long name, but what I did furthermore is I referred here just to the class object instead of mentioning the name of the class. And what kind of different, and by the way, I renamed it a little bit. And what difference does it make? Yeah, let's have a look in the generated code again. We have again now a builder object, but it is now a string concatenation client. And we have this builder this builder pattern implementation here. Skip most of the parts because it doesn't matter here. But the difference is the elements or the parts of the template, like this public class declaration, are not applied immediately to the client, but the client again receives another builder object from outside. And this way we are somehow able to track, for instance, references of classes. And this is done like this. So we create this generate class as a fully fledged method, instantiate a string concatenation of our own, tweak it a little bit, and finally apply the former mentioned code generation template to this concatenation. Last but not least, we have another template stating the package, now stating all the imports that we have tracked via this tweak, and finally append the content of our Java class declaration. And with this, we get the result that we want to obtain. And I show you this in just a few seconds. So first, I need to sync. So what I do have here in my Eclipse instance, I have these both templates, the generate class declaration. I have these further methods, and I implemented the tweak method basically. And if I run this code now, we get in the console our Java class as we would like to have. And if I, for instance, say I tweak it a little bit, I change the name here, and I tweak the methods and remove the import tracing, run it again. The import is missing, and we see a difference. So this basically works, and if you would like to, just give extended. If you also want to use this, give extend a try. But this is not all we can do with extend. The more advanced stuff is presented by Moritz right now.
Question about the indentation thing. Is it that you need to write different kinds of white spaces in there? Or
right, maybe I can. So the question was, referring to the slide of Christians that showed significant white space, and where Christian showed significant white space, or what we also like to call gray space, and the white space, insignificant white space, so that doesn't go to the output. And the question was, do we have different keys on the keyboard for this one, basically? No, it's both the space bar, so it's both the same character. The edit or extend is smart enough to distinguish based on columns. So for example, here you can basically see a gray column with interruption, but basically it's a column. And this column is significant white space because at the very top there's output. if we go one column further, for example here, and go to the top of this column, at the very top, there's a template instruction. And that's why this column is not significant out of white space. Approximately, this is the approximation how this works. But it's, in my experience, it works really nicely. And you usually don't need to think much about it because you type it in the editor, and the highlighting of the editor explains to you whether it's white space or gray space, and it works.
Can you also show significant new lines and insignificant new lines?
New lines are always significant.
Not so, the new lines behind here are not significant, for example. So I mean, the Eclipse editor can highlight new lines, but I need to check whether we highlight them gray or not.
I think you can do once you activate these control characters, so the dot for the space and these kind of arrows for the top character, and then you see also differently colored returns.
As a rule of thumb, if there's a line that contains nothing but a template command, like for or if or else or end if, the trailing new line is not significant, and for all other lines, but let's continue, because I wanted to get to the next chapter, being tracing. So, what's a trace and how does it relate to code generation? Most simple definition I could come up with is trace is something like a mapping that maps generator input to generator output. So you feed a model into the generator and get some text, and the trace tells you what element from the input relates to what part of the output. For Xtext, to be more specific, since Xtext parses in DSL documents and generates source codes, it means we have text as input and text as output, so we can relate text regions. Text regions from the input relate to text regions from the output. And once we have this trace, we can do quite nice things, like this one, for example. Here I'm using extend, the language Christian just showed, as an example. So here we have an extend file, and here on the right-hand side we have the generated code view. It's a view that extend ships with. So if you write something in extend, this view can show you live how the generated code looks like. And now, if I move my cursor here on the left-hand side through the extend file, the generated code view will highlight the corresponding generated text region. So a text, for example, a print line invocation here in extend obviously led to this method invocation on the Java side, and based on the trace we have this very direct mapping, which can, let's say if you have a more complex code generator, more complex models, it can really help to figure out if generated code is not as it should be, to figure out where does it actually come from. But that's not all. Quite obviously, we can have context menu entries. So I need to go back. Here I have another example. This time it's not extend. This time it's a small little language, Xtext language that I created using Xbase. So a reusable expression language that ships with Xtext. And that language gets compiled into this Java code, obviously. And Xbase languages and Xtext are tracing enabled by default as well. And those languages also get these little entries in the context menu that I want to show. So here, click onto the source file on show generated source code, and it goes there, and then you go here to generated source code and click open source file, which will upload your source code to Eclipse and turn your proprietary product into open source. No, I'm kidding. it opens the source file this way, this information. So there's context menu items to go from the DSL document to the generated source code, and from the generated source code back to the DSL document. Yeah, let's go a little bit more into the technical details. Here now I have this Xbase example again. Now the example script is on the right hand side and the generated Java code is on the left hand side. And down here is our trace file editor. This editor is not supposed to be used by users at all. I mean, it's more like for the person who needs to make sure the traces get created properly. I just wanted to show it here. We can see the file with, here's the print statement, for example, and here we can see it's surrounded by region 10, begins here, region 10 ends there. So then I can go here to the left-hand side and also find region 10, and here region 10 starts here, ends there. So I, as a developer, can confirm quite quickly which text regions are related. And down here, region 10 is some entry here in the string. It's not for the user, it's more for the person who needs to build the code generator. But there's more. About tracing. I mean, the features that I showed so far are nice, but probably not really enough to convince anybody to say, yeah, I need to introduce tracing to my code generator. But there's one more thing you can do with tracing, being debugging. When I say debugging, I mean run the generated code in a runtime and let the user debug it, but the user shouldn't see the generated source code. The user should see this DSL document. And that's what we can do with traces. The question is, what do we need for it? Obviously, a trace. Xtext can provide that for languages. But secondly, we need a source line mapping aware runtime or debugger. And luckily, JVM, the Oracle JVM, is exactly that one. So there's JSR 45, who defines this SNAP format, which is in fact a source line mapping. This SNAP format was developed by Sun to allow debugging of JSP files. Remember Java server pages? Java server pages are also compiled into Java code level, so if you want to debug Java server pages, you need to work with this SNAP stuff as well. And good for us, we can use it for all DSLs because it's not specific to JSPs. But the JVM is not the only runtime. Some web browsers support source maps as well. There's Chrome, for example, that supports source maps. So you could generate JavaScript and have a source map map the regions back to your DSL, so you see your DSL code. Right, but let's go a little deeper on how that works for Java, actually, conceptually. I mean, first you need to create the trace files, or the generator needs to create the trace files. The next can convert those trace files into these SNAP blocks, I mean, a piece of text as well. And the next can install those SNAP definitions as debug information into the Java bytecode that has been created from the generated source code. So it's basically generated source code, compiled to bytecode, and then enhance this bytecode with the SNAP file. And that's it. And that's all we need for the Eclipse debugger, for the Eclipse JDT debugger, for example, to allow debugging. So here now again I have my little Xbase example, and I open the file and I go to the line, and then I trigger a toggle breakpoint on that line. and then I go to the Java file and say, it's the generate Java file, and say run as, or not run as, debug as Java application. And just as we know from Java, Eclipse asks us new perspective, yes. And we are inside the Java debugger, and we have stopped at our breakpoint. And the debug view shows the invocation stack to that location inside the DSL. And we can do step over, we can also do step into, and down here in the console we can follow that this code is really executed. But even more interestingly, we can do a right mouse click on our stack frame. And in our context menu, we invoke show source and we switch to Java. And now we're debugging the generated source code. Usually you don't want to do that, but it could be that to go even deeper technically, that it's quite handy. And then go back to our DSL and keep on debugging. So much about debugging, but we have more topics on the agenda. So next big topic would be the question, we have a model, but what if the model is not enough? Question is, what do I mean by the model is not enough? We have seen many projects where people define in their DSL files model really nice structures, but when it comes to expression behavior or logic, then they fall back to Java. We see this in EMF, for example. When in EMF you define your E-classes and the references and the attributes and the operations and the signatures of the operations. But when it's about implementing the operation, you need to go down to the Java code and modify the generated Java code. EMF has this generation get pattern-like approach here. It puts a generated annotation in front of the generated method, which basically tells the code generator if there is a generated in front of a method, you can overwrite it. But if the user has removed a generated from a method, then the code generator is not allowed to overwrite that method. So the generator leaves the handwritten method as the user has created it. Yeah, that works. Then another pattern we've seen a lot and we've actually used ourselves as well, so we like to call the generation get pattern, which involves two files now. So the code generator generates a file into a different source folder, like source gen, for example. Generates all the Java methods inside that it wants to generate, marks them public and protected, because in our source folder there's another Java class extending the generated one. So in our subclass we can overwrite any Java method from the generated superclass that we want to customize. Which is nice because now we can completely delete, throw away our source gen folder regenerated, because in here there's no customized code, because it's all here in our source folder. And the source folder obviously is not touched by the code generator. And then there's Eclipse as a reusable expression language. So here, for example, I have a little DSL where, let's say, I want to define some rules. So what I, as a language designer, would specify is that I have a rule keyword, and then the rule has a name, and then the rule needs to be specified somehow. And that can be complex because I need logic, I need arithmetics. So a good match for cases like this is, instead of falling back to Java, make use of XSpace. So XSpace has these X expressions that can be reused in a DSL applications like this one. And it's really easy to apply because if you create an access grammar, you extend XSpace. And once you extend XSpace, you can call the parser rules from XSpace, expression down here. Yeah, so it allows to integrate powerful expressions into any kind of DSLs. It allows to do call-outs to Java, like access Java fields, invoke Java methods, but it also allows call-ins from Java. Java can call the code that you generate, obviously. We define context also with expressions. In the JVM won't infer, by context I mean we define what classes are visible, what fields are visible, what methods are visible, and so on. And there's an existing expression to Java compiler, part of the space, of course. Yeah, to wrap up this topic, I like to distinguish these three approaches based on two criteria. One criteria is it's a generic source code. Do I need to put it under version control? I think that's a really interesting question. And I mention this because if you look with something like JMerge in protected regions, then yes, you're mixing handwritten code and generated code, so you're required to put it in version control, which can make code reviews quite nasty, because then your code review will not only have human crafted changes, but also generator crafted changes, and generators like to craft a lot of changes. Then with the generation get pattern and with the X-space, here we have two different source folders, so I can delete my source gen folder. In this X-space, I just generate code and throw it away anytime. So there, I don't need to put it under version control. The other question is, do users need to read and write the generated source code? Or in other words, is my abstraction leaky? Can users do all the work with a DSL document, or is the DSL expressiveness of the language not strong enough so that users need to fall back to the generated code? Like, break through your abstraction, go one abstraction level lower and edit the source code. And yeah, with JMerge protected regions generation gap, yeah, that's the case. Maybe you want users to work with Java, but if you want to build a sound abstraction, then it's much nicer if people don't need to go down to the Java code. So it's not necessary with X-space because their expressions are inside the DSL document. Then for the last chapter, I promised to talk about proven strategies to test code generators. What I found interesting on how diverse approaches are is that they all have their advantages and disadvantages. First, and I guess the most simple one is generate code and compares generated code with handwritten expectations. Works nicely, it's really fast. However, it only works for very small things. Like when these handwritten expectations get bigger as 3, 4, 5 lines, then it's not fun anymore. We use this approach, for example, to test the X-space compiler, the extend compiler. Then another interesting approach is generate code, compile it, and run it, and take the result of the execution. This is really nice because then with this approach you're not testing the text that you generate. With this approach you test the execution semantics of what you generate. That offers a lot of flexibility because you can totally refactor your code generator and your tests will remain green as long as the generated code behaves the same, even though it may totally look different. Example, at some point you decide to introduce some very intermediate variable into generated code. With that approach, here in scenario 1, a lot of tests will break because the generated code looks different. But with scenario 2, all tests will remain green because the generated code behaves the same. Because in terms of execution semantic, a temporary variable does not make a difference. But there's more. We've had projects where we wanted to replace legacy generators. Then it's nice to take real-world projects and generate them with the old generator and also generate them with a new generator and then compare the output of both generators and see if it matches. Usually we don't want to match it 100% because it would be too much effort to do a perfect character identical match. For example, it's quite useful to ignore white space when possible, ignore comments when possible, and maybe agree on a small set of accepted deviations between the legacy code generator, because what we've seen is that most legacy code generators work quite good, but in some corner cases they do stuff that we really do not want to implement again, which are more like a result of some quirks and not really design behavior. And of course, there's another approach, generates a code, and takes the generated code as a test expectation, and then change the generator a little bit and test again against what you previously generated. That approach, of course, will not find bugs that have been there in the generator from the beginning, but that approach does save you from regression bugs. So with that approach, you can incrementally improve the generator and at the same time make sure you do not accidentally introduce regressions. Yeah, so that's 4 approaches. Thank you very much for being here. Do you have time for questions? No, there's unfortunately no time for questions, but Christian and I will be at the booth or at the
coffee table.
At the coffee booth outside. So we